Hello, I'm Pat Conway. I am the math coach for the SVSU, and this presentation is a recording of what actually happened on the BSD, Bennington School District, their parent math night that we had. So we're re-recording it for your benefit. The whole purpose of this presentation is to support your K-1-2 student, your child, with their math education, the support you can offer at home. This topic is nifty numbers, adding and subtracting within 100, because that is the focus area within K-1-2. I'd like to thank Laura Boudreau, our Director of Curriculum Instruction and Assessment, and Sally Basacchio, our Tech Integration Specialist, and I'm Pat. So Sally, let's start talking about numbers. We're going to get started with vocabulary. There's a specific math vocabulary for each grade level. We have word list, what the meaning of the words are, and examples of how they're used. There's a list for kindergarten, first grade, and second grade. Those lists live online at the SVSU webpage. You can go to the curriculum part of that site and work your way through. You can always email me and I'll send you a copy also. Sally? Vocabulary and opportunities for math vocabulary are everywhere. It's an example at the grocery store. Words for kindergarten, how many, what's more, what's less, above, below, those type of directional words. The tomatoes, are they above the cucumbers? Are they below the cucumbers? Here we have things in the kitchen. How many knobs are on the stove? How many carrots are on the counter? Is the colander smaller than the pot or bigger than the pot? Here we have at the playground, how many swings there are. Are there more swings than seesaws? Are there fewer seesaws than swings? Does that mean the same thing? When you're in the car, you have a captive audience. Speed limit sign, 30 miles per hour. Talk about how fast that is with relation to other numbers. Okay. Sally? Thinking strategies. Thinking strategies are appropriate for K-1-2. Not the strategies that you as an adult think with, but the strategies for children. Sally? Why do we think with these strategies? It's a better way of understanding, having conceptual understanding, not a procedure of how we do, but why we operate the way we do with numbers. We're going to think like a young learner today. The problems that we'll be solving, the strategies that we're going to talk about, we are in a K-1-2 frame of mind. We're not going to think like the adults this evening. There's tools that we'll use in the math classroom. Math hands. We have the children shake their hands out, they put them on their lap. Show me what 4 looks like. They'll hold up this. What's a different way for 4? 3 and 1. We're using our fingers, our 10 digits to show the numbers. 1 penny whiteboards. That is a dry erase board. It's a clear plastic sleeve with cardstock inserted in it, and it's a writing surface that can be written on and wiped off with an eraser. Dice and spinners. These are not your dice that have the 1 to 6 sides. Most of the dice that K-1-2 use, we have a 0 to 9 die. We have a die with 20 sides, and we have place value die. 0 to 9, 10 to 90, and then 100 to 900. The 100s chart, we'll see one of those in a little while. We'll talk about number paths and number lines, number bond, number triangles. These are all about relationships for numbers, what base 10 manipulatives are and how they're used, and then we'll look at problem models for kindergarten, first, and second grade. Sally? One of the earliest thinking strategies for kindergarten is the 5 frame. I call it a 5 frame because it has 5 separate sections, 5 separate squares. 5 frame we can use to model what? 3 and 2 more, how they make 5. Sally, do you want to show us that? Here Sally's showing us a quantity of 2 red chips. Now she's going to show us 3 blue chips, and we see that it does fit the frame. Now, kindergartens wouldn't be writing a number sentence for this problem. First grade would, but it's the language, the vocabulary. I had 2 red chips. I have 3 more chips. Now I have 5 chips. 2 and 3 more is 5. From the 5 frame, we go up 1 level to a 10 frame. We have the 2 5 frames together. Now filling out the frame is important. Sally, let's show us how 8 is really a 5 and 3 more. Sally's going to show us 5 blue, and she's going to start filling in from the left and move to the right. This is the way we want you to fill in a 10 frame with your child. We will have 5 blue, and we'll have 3 more. And we see that an 8 can be decomposed, broken apart to 5 and 3 more. When we have a quantity of 8, we can clearly see on the 10 frame that 2 more would give us 10. 5 and 10 are benchmarks for kindergarten. Sally? And then first grade works with the 20 frame. With the 20 frame, 10 and 10 more. Sally, let's look at a number on the next slide that we have. Here we have 10, and we quickly see that it's 5 and 1 more for 6, that we work with a teen number. 10 and 6 more is 16. And again, we have that perfect visual that 4 more is 20. 5 frames, 10 frames, and 20 frames. Another strategy for kindergarten is a number path. This is a number path. We have a number line. The number paths, putting numbers amounts together, counting on and counting all. We want to discourage the finger counting. We don't want this in higher elementary. We don't encourage that. On a number path, we can think of, well, if I have 2 and I move 3 more, 2, 3, students are counting. They're not on their fingers, they're here. This visual for the number path, we go to a number line. The number line, we have 0. You can say that there's a 10. We start about magnitude of numbers. Where would the 9 be located on my number line? In the beginning, we're pretty happy if the student is beyond the halfway point and we don't have a 9 over here. But number lines are not for kindergarten. We first introduced number lines in first grade. Sally? Making a 10, that is a milestone in first grade. Here's our number line, and here's the beginnings of a problem. How many more berries to have 10 berries? Well, we have student having to count these. Now they're in a scattering, they're not in a straight line. So some students might count and repeat counting. So even counting itself is a skill that children learn in kindergarten and first grade. So we have a quantity of 7 berries. We can start from 7 and count on to have 3 more. We don't want to encourage is counting up to 7 and then counting on. We have that jumping off point. Sally? This is a hundreds chart from 1 to 100. Hundreds charts are always organized like this. We see that in the sequential rows, the relationships, it's 10 more, 1 more, 10 more, and 1 more for 11 more. These are the patterns that children will investigate and explore within the hundreds chart. Children that are in first grade will have a chart that goes from 1 to 120, but this is where they start with the hundreds chart. Sally? Here's another model for first grade. These are called number bonds, and the number bonds show the relationship between numbers. You see the arrow that's in each of these models? Pointing up, down, or north, south, left, right, or west, east. There's an arrow in every one. The arrows point to the whole. You might see a number bond for 5. It's decomposed, that the 2 and 3, so 5. Maybe we have a number bond showing 10. Or a number bond that 16 and 2. Or first grade would work with that. So no matter where the arrow is positioned for what direction, it's pointing to the whole. Okay. But there's more. Sally? The number bond, it doesn't allow us to work with the magnitude of the number, magnitude being the size of the quantity and that kind of comparison. So Sally, let's take a look at how we can help students with this. This type of model is called a part-whole model. The entire quantity is 10. The 2 parts, 8 and 2. See the size of the 8 and the size of the 2? That's the magnitude of the number. Sally, a little bit lower and we'll be able to see that the whole is 10. Might see some print resources where the whole is on the top. It's the same idea. It's a part-whole model. The difference in the number bond shows the relationship, but with this model, we get to see the magnitude of the numbers. Okay. And then the number sentence. Number sentence, we might call it an equation. For kindergarten, first and second grade, we're going to work with number sentences. We have 8 and 2 more equals 10. 8 and 2 more is the same as 10. That's the vocabulary that we're using. Okay. Sally? This number bond, the result is unknown. We don't know what the whole is. Sally, what's our next thought going to be? A part-whole model. So here, the unknown, the result unknown, the total. Here's the part-whole model that a student would work with this number bond. 4 is slightly smaller than 6. And our equation for this, Sally? Number sentence. 4 and 6 more is the same as 10. So these are models, visual models, to help with putting numbers together. Okay, Sally? Here's a number bond that one of the parts is missing, and we see our numbers are larger. This would be appropriate for first or second grade. What are some possible thinking strategies? Now, as an adult, you might be thinking, well, this is a subtraction problem. 23 minus 19. And I'm going to cross out and borrow and carry. Remember, we are first and second graders. Sally, let's look at what some of the possible thinking strategies for this grade level are. This number bond is really an addition equation. 23, and it's not backwards. It's okay to have the 23 on the left equaling my expression, 19 plus how many more. One of the related fact families for 23 equals 19 plus what? Is 23 minus 19 equals, yes. Anchor 10, In anchor 10, those are your 10s, your 20s, your 30s. And anchor 10 would be, one more takes me to 20, and then 3 more takes me to 24. So, or 23 rather. So 19 plus 4 more is 23. Number line, students can model on a number line that counting up. I'm located at 19. 4 more jumps or hops to 20, the counting on, base 10 blocks. And here's a part-whole model. And I have a little bit more. Should I see the bottom of the model, Sally? There we go. So I know the whole is 23. Whole model is 23. And I have 2 parts. Thank you. One part is 19 and one part is 4. To help with the magnitude of those 2 parts, I think I'm going to go right about there. I said, I think I'm going to go about there. That's an estimate. We're not going for exactness. We will see, and children start with this, counting off for 23, but it's an estimate that 19 is a much larger number than 4. It's a greater amount. And there's our part-whole model. Number bond, thinking strategies, magnitude representation. Okay, Sally. First grade could also use base 10 manipulatives. 1 single unit. A 10 can be thought of as a bundle of 10 ones. Now, we don't call these rods or sticks. Some of the manipulatives in the classroom are yellow. We'll call them French fries. No, those are pet names. We're speaking with precision for vocabulary. So this is a 1. This is a 10. Let's look at what it looks like to think with these. 24 ones is the same as 2 10s because it's a bundle. That's one of our benchmarks, 10, and 4 ones. This understanding with 10s and 1s, first grade, builds to our next grade level. Second grade understands that 100 can be thought of as a bundle of 10 10s, and that is the vocabulary that we use, bundle, group. This is called expanded form, where we've taken the quantity 124, and hear yourself say that, 100 plus 20 plus 4. So let's see what it looks like with operating with expanded form. Here we have an example, 2 quantities, both in expanded form. We do have the place values aligned because we do think we add hundreds to hundreds, 10s to 10s, and 1s to 1s. Now remember, this is a second grader. They're not going to do column addition, that traditional algorithm that we do as adults. 4 and 5 is 1. My 1s are added. Grouping my 10s together, 20 and 50, 70. And I have no hundreds in 51. My answer for 24 plus 151 more is 175. This is expanded form addition. It's what you're going to see first grade, second grade. You'll see this in second grade with numbers within 100 and over 100. Sally, let's look at where this leads to. This is the very beginning of regrouping. This is that borrowing that we're so tempted to do with the little crutch numbers. Please resist the temptation to think 8 and 7 is 5, 15, put down a 5, carry 1. Don't say, here, do it this way. 8 and 7 is 15. 15 ones. 30 and 40, 3 tens and 4 tens is 7 tens, which is 70. 70 and 15 is 85. That's the concept behind the regrouping that we do as a procedure. Adults take procedures for granted. We're building understanding in our young learners. Okay. Sally, let's see where this is going. Grades 1 and 2, they use manipulatives to add and subtract to build understanding of place value. Through understanding, they will get to the procedure that we take for granted, and I'm asked, oh, well, when? When are students going to learn how to do that? The understanding builds in K1, 2, 3. By the end of 4th grade, fluency with a traditional algorithm is expected. Some problems for us to practice on. Joe has 24 marbles. His friend has 32 marbles. How many more marbles does he need to have the same amount as his friend? You might think of this, excuse me, as a subtraction problem. Children learn that subtraction means that you're taking something away. Nowhere in this problem are 32 marbles as a start and we're losing 24 of them. That's not what's happening here. This is a comparison between Joe's marbles, 24. He needs more to have the same amount as his friend, which is 32. Sally? What does it look like when you think with base 10 blocks? Remember, students have access to manipulatives. With base 10 blocks, we would build 24 as 2 tens and 4 ones. The total that we want is 32. 24, 25, 26, 27. I need one more. Thank you. Now I've got 30. 2 more. Now I have 32. From my 24, what did I give? I gave 8 more. My answer is 8. Joe needs 8 blocks to have the same amount as his friend. Okay. Sally, was there anything else on that page? There we go. What does the number line strategy look like? Remember, the number line is introduced in 1st grade, and children work with it extensively in 2nd grade. I'm going to start at 24, and I want to get up to 32. Remember those benchmarks, those anchor tens? Well, 24 and 6 more. Now I'm at 30. This was plus 6 more. And 2 more will hit my target of 32 marbles. Joe needs 8 more marbles for 32. Children will start off with single jumps or hops. And then once they have the benchmarks, 24 and 4, they can do that. 24 and 6, they can do that all at once. Base 10, number line. Sally? Can't stress it enough. Don't teach ahead. The procedures and the strategies that we as adults use are not for our young children, our young learners. Procedures come from understanding. We have to have the conceptual understanding first. Then we go to an algorithm and procedure. Sally, I think we have some more problems to work on. Here's our principal. 87 pencils. But there are 91 children in 2nd grade. How many more pencils does the principal need? If you're thinking 91 minus 87, and you go to your regrouping, it's not how a 2nd grader is going to think. We can think on a number line, that I have 87, but I need to be at 91. Well, 3, I'll be at 90. And then one more pencil, I'll be at 91. I have 87 pencils. Sorry about that. And I need how many more for 91? I see from my number line, this is called an open number line because I don't have every individual number marked on it. 87 and 4 more. 4 more pencils. Okay. We're thinking like second graders. Sally, we have another problem. Let's see, we need some space though. This problem, the result is unknown. You count 18 blocks in the box. You count 29 blocks on the floor. You put all the blocks in the box. How many blocks are now in the box? I'd like to point out the language here to you. Notice it does not say how many blocks in all, how many blocks all together, how many blocks total. Okay? Those were once taught as keywords. We teach for understanding of what's happening in the problem. So how many blocks are now in the box? The understanding is that we need to find a total. Those key words that we used to teach for, that, look for in all, look for total, look for together, that means to add. Where's that word here? The understanding of what the problem is about, the concept, that is how we know to add these. So how does a second grader add these numbers? Okay. A second grade, whoops, what's that? Okay. A tech surprise. A second grader does not think 8 and 9 is 17, put down a 7, carry 1. That's your adult procedure. A second grader, their strategy is going to be expanded form. One of the strategies that they could use. The 18 plus 29. 18 expands to, 10 and 8 more. 29, do you have it in your head what you think I'm going to write? Are you thinking 29 more? Great. I'm all done writing my numbers. 8 ones and 9 ones is 17 ones. 1 10 and 2 10s is 3 10s. 3 10s is 30. 30 and 17, well, 30 and 10 is 40, and 7 more is 47. There are 47 blocks in the box. And we would say that 47 blocks because labeling is important. Here we go. Now there are other strategies. A student might want to take 1 from 18 to make this 30, and 30 and 17. But expanded form is a strategy to focus in second grade. Okay, Sally. We have a summary. Let's look at what we did this evening. Grade level vocabulary. It's on the SVSU website on the curriculum page. We're going to show my email up here. You can also email me for it. You're going to speak with precision, the same vocabulary that your child is using. Number bonds, 10 frames, 5 frames, expanded form, above, below. Models for thinking about numbers. The model for the magnitude of the number, the part-whole model. Numbers for operating with numbers, the frames, the open number line, the hundreds chart. Models build conceptual understanding. Without models, we're blindly doing a procedure. strategies for problem solving, the models, the visuals, gaining entry into a problem. Without an entry, we have frustration, and then we have adults who don't like to do math. Common Core State Standards for Math. There are 8 math practice standards, generalizations that we want as good mathematics strategies. The 2 in our supervisory union that we're focused on, practice number 1, to make sense of problems, understand what's happening in the problem, not relying on key words, and then persevere, push through to a solution. Attend to precision. You might think that's, attend to precision, that's measuring twice and cutting once. Attend to precision is the vocabulary of mathematics. The vocabulary, those word lists, no pet-friendly names, the correct math terms. If you have questions, okay, not here, so you can't ask me right now, but you can email me at pconway@svsu.org. You can go to the SVSU website. There's contact information on there. Please, we love to talk about math and math thinking, the system of numbers. Be happy to answer any questions or help you so you can support your child in their math education. Thank you.